Alright, very simple. I want to deal with mapping and function. Alright. So what is mapping and function? Let's start with function. That one will be very easy for you to understand. So when you say function, this is what it means. If I say f is a function of x, and the function is defined by 3x plus 2. Now, if I have f of 2, I will get something like this, 3 times 2 plus 2. What did you see happening here now? You saw that these two, filling in the gap for x, also represent x in the, also represent what? X in the original formula. So it can be 3x plus 2. So whenever we add x, we replace it with 2. So it can be 3 times 2. 3x means 3 times 2. So 3 times 2 plus 2. And at the end of the day, you have what? 3 times 2, that is what? 6 plus 2. And it gives you 8. This is a function. So what did you see? It's a rule. Alright? It's a rule. Alright? And it is a rule. It means that any number you have there, you must multiply by 3 and add with 2. It's a rule. So function is like a rule. Alright? So what is mapping? Mapping is a set of rules. It's a rule. Alright? That allows a set to produce another set of numbers. For instance, if I have a set of numbers 2, 1, 5, 6. Alright? Now, if this set under this operation or under this under this function produces another set, then we have that 2 will give us what? When you put 2 here, what do you get? 8. I hope you understand that. So 2 by this function will give you 8. 1 by this function will give you what? So when you put 1 here, let's try 1 again. So let's try 1. So f of 1 is follow this function. So we are replacing 1 for x here. So 3 times 1 plus 2. Alright, so 3 times 1 plus 2. Anywhere else if you put what? 1. 3 times 1 plus 2. 3 times 1 is 3 plus 2. Altogether is 5. So 1 will give you 5. And 5, when you put 5 here, that will be 3 times 5 15 plus 2. That will be 17. 5 will give you 17. 6 will give you 3 times 6, 18 plus 2. That's 20. This is what we call mapping. So mapping is when it is a set of is when a unique set of numbers, as this unique set of numbers under a particular function produce another unique set of numbers. This whole thing is called mapping. And see, we're mapping out following a particular rule. You understand now? So there are types of mapping anyway. But I hope you understand this mapping. So now this first set is called domain. Please take note. The first set is called domain. Alright? Now this set is producing another set called what? Co-domain. Are you with me now? Good. Now, the truth is that this set, are you getting me? This set can be infinite set. Even if it's not infinite, this set might end up having some of them producing the same number. You understand me? That is under a separate rule apart from this rule. You understand what I'm saying? Okay. So let's try. Let's look at this again. I'll give you another rule. Now, watch another rule. So let's say f of s is f raised by 2. Alright? So when you put f of minus 1, what do you have? You have minus 1 raised by 2, right? So minus 1 raised by 2 will give you 1. True or false? Good. Now, if you have f of minus 2, what will that give you? Minus 2 raised by 2 will give you what? 4. True or false? Now, f of 1 will give you the same value as f of minus 1. Can you see? So you have two different sets from the same domain producing the same element in the codomain. Alright, so what am I talking about? I'm talking about 1 and minus 1. Both of them will give you both of them will give you 1. You understand now? Alright? So I have all that. Alright, so let's look at types of set. Now, the first type of set I want to explain now is what we call one-to-one, types of mapping. The first type of mapping is one-to-one mapping. Let's look at that. So, one-to-one mapping, look at this set now. One-to-one mapping, or look at this mapping. One-to-one mapping, every element in this code domain, every element. When I say element, I mean all the members of this set. These are sets. This is a different set. This is another set. Alright? They are both unique sets. Alright? Every element of this set is produced by what? A unique element from the what? Domain. I think all of them have one by one-to-one. Let's use that. Let me use that to name out on the one-to-one mapping. I think all of them have unique set. Unique what? Set. Alright? So now this one is not coming from this one, that is coming from this. Now look at the previous example I gave you. When you have -1 and 1, both of them are giving you 1. Both of them are giving you 1. So this is not a one-to-one mapping. Why? Because this one produces one, this other one produces one again. So it's not a one-to-one mapping. Because you have two or more elements from what? The domain, giving you one element in the whole domain. You see that now. So one-to-one is when every element has a unique, every element or element in this whole domain has a unique element or produced by a unique element in what? The domain. I hope you understand that language now. Unique element in what? Domain. This one is not unique. Both of them are producing one, so it's no longer unique. So it's not a one-to-one mapping. Do you understand that? Now, by the way, all the elements in this code domain are called range. What is range? Range is the element that are produced by the element in the code domain that are produced by element in the domain. I hope you understand. That is range. So that one is called image. That's called what? Image. So this is an image. Y is an image of B and X is an image of A. So all the images, the collection of all of them put together is called range. Now what does that mean? That means that if I have an extra element here that is not produced, okay, let me call it another element M, that is not produced by any element from this domain. Do you understand? There can be an extra element that is not produced by any element from this domain. You understand? So that one is not an image. You understand? It's not what? An image. But the ones that are produced by elements in the domain are called image. So the collection of the image is called range. Alright? The collection of the image is called range. Meanwhile, the total element, both the ones that are produced by elements in the domain and the ones that are not produced by elements in the domain, all of them put together are called whole domain. You understand it now, right? So let's try the next. Now the next type of mapping I'm going to discuss is what we call onto mapping. What I call it? Onto mapping. You know I discussed one-to-one. Now we're talking about onto mapping. So look at onto mapping. Now, what is onto mapping? Onto mapping is that every element here is an image. What I say, every element in the whole domain is what? An image. So let's try. Let's look at S, Y, Z, K. So S is A. Alright, we are zooming though. And you know all these variables are representing numbers. I hope you know. And they are following a function, either function F or any other function. So let's go F for now. Now, C, and D. 1, 2, 3, 4. All of them are produced by what? Element in where? In the domain. So there's no one left that is not produced. There's no one left, let me call it there's no one left that is not produced by element in the domain. You understand? If there's anyone that is left, like this one now, if it is here now, then it is not an onto mapping. It's not what? Onto mapping. It's not onto mapping. Alright? Why? Because this is it's not an image of any element in the domain. I hope you understand. In the first one, I said there's no unique, all of them are unique. Like this, there's no one that is producing there's no 2 that is producing the same element, right? No 2 producing the same element in 1 to 1. No 2 producing the same element in 1 to 1. All of them are produced by 1, 1. All of them have their own 1, 1, 1 to 1, 1 to 1. No 2 produce the same element. But in this one, onto mapping, there is no extra one that is not an image like this one now. There's no extra one that is not an image from this domain. So this one is not there. So this is onto mapping. Alright? But if this one is here, it's not an onto mapping because this one is not an image of any element. Do you understand now? So now, there are some mappings that are both onto and one to one. Like this one now is onto and one to one. Why is it onto? It's onto because there's no extra one that is not having that is not an image of the domain. Two of us. Yeah. Then why is it one to one? It's one to one because this X and Y is not producing the same element. There's none of them there's no 2 of them here that are producing the same element. I hope you understand that, right? Yeah, you understand it. Let's try another type of mapping. Now the other types of mapping are the constant mapping. So what is constant mapping? The constant mapping is the one that the element in the domain produces itself in the codomain. So S produces S. Y produces what? Y. So that is a constant mapping. It doesn't change. It's a constant mapping. I hope you understand. Now the next mapping is inverse mapping. What is inverse mapping? Inverse mapping is how to do the inverse of the element. Inverse mapping. We're going to do calculation of that. So let's not bother about that. Alright. Now the next one is what we call composite mapping. That's where the focus lies. Composite mapping. Composite mapping. What is composite mapping? Composite mapping is when you have extra set. So you're having another function, right? So you have one function here. Let's say this function is x, and I have another function here, g. So what do you have? You have 2 or more functions, 2 or more functions combined together. That is composite mapping. I hope you understand. So we'll do calculation now. Alright? Alright, now let's do calculation. So let's assume a mapping is given as f of s as what? 2s plus 5. Alright? And the same to find f of minus 1, minus 2. So how do you get f of minus 2? That will what? 2 times minus 2 plus 5. Minus 2 is representing s. I will replace s. So what do you have? Minus 4 plus 5. That is what? 1. Did you see that? Is that easy? Good. That's the first question we'd like to try. So now let's assume there's another function h. H of s. H of s is 2x. Let's say 2x squared. 2x what? Squared. So if they ask you to find h of minus 1, so h of minus 1 will what? 2 times minus 1 squared. You can square this minus 1 before you multiply by 2. So that will what? 2 times minus 1 squared is 1. 2 times 1 is what? 2. You understand that? Can you see that? Very easy, right? Good. When it's opposite mapping, it has to combine two. So let's assume they ask us to find h of f. H of f means you are combining two functions now. You are putting f function inside h. So let's try that. So that means h of f. So what is the function of f? Look at the function of f here. Now 2s plus 5. So this 2s plus 5 will replace x, just like the way ordinary number is replacing x. 2s plus 5 will replace x under h, under the function of h. So this is the function of h. So now have this will now give us what? 2 open bracket 2s plus 5 this is 2. Now this 2s plus 5 is representing this s here. Can you see it there? So this 2s plus 5 is representing s just like what you have here, alright? So both of them are representing s here. And I told you have to square this. Simplify this square before you work on it. So what you have? 2 open bracket. Now when you square this, it means what? 2s plus 5 and another 2s plus 5. And how do you multiply this? Let's go. So 2s times 2s, that's what? 4s squared, right? Now 2s times 5s, that's what? 10x. Now 5s times 2s, that's what? 10x. 5 times 5, that's 25. Are you seeing that now? So what do you have? 2 open bracket 4x squared. Now, add the one that you need to add. 10x plus 10x, that's 20x. 20x plus 25. Eh? Now, use this to multiply. So let's go. 2 times 4x, that's 8x squared. Plus 2 times 20x, that's 40x. 2 times 25, that's 50. This is your answer for that composite mapping, h of x, right? So you try f of h. Both of them are not the same thing. You carry s and put inside h in this one. This one now you are carrying h and put inside s. So try this one and let me see your answer.